some of the magics, and then you will find that there is a lot of science behind the magic. Okay. Each of these experiments can be demonstrated for a longer time, giving all details and equations and all those things. But I'm not going to do that. I will just show you. Those who are interested can contact me later. I stay in Anushakti Nagar only. See, here I have a blower machine. You may be knowing it's called industrial blower, and you can see that ball is floating in air. My question is, why the ball is floating in air? Huh? Pressure is exerted by, but why it's not going off? Why it is staying in that particular position? Yes? If both the sides.
तुम्ही सर रिपीट करा जे बोलते थे तुम्ही रिपीट
But miss, you are saying that pressure will be from both the sides, but you can go to some other side, no? Not necessary to go in particular side. Yes, please.
Because of the round surface of the ball, the air is flowing from the sides, it's not staying in one position.
Okay, very good. She is saying that shape of the ball is round. That's why that air means that ball is getting balanced. Any other answer? Please. You can see here. Did you observe what happened? I was doing this, and this ball, this balloon, it gets attracted towards this machine. Why is it so? Because this works as an exhaust fan. The air comes out from this, but it is taken from this end. And when it comes from at this end, then it's like a vacuum cleaner. Whatever dust particles are there, they will be pulled here and they will be stored in some bag. Here, suppose when I take this, okay. Now we just see, if I take this ball, now the question is why this ball is thrown out. Tell me please. Now I'll take another ball. If you observe very carefully, when I switch off the machine, the ball instead of going off, it gradually comes and settles here. Why? You should ask this question, there should be inquisitiveness, why the things are happening. Now I choose one more. See. Now when I switch it on, ball is here. Now I will gradually change the direction. It's not falling. I can bring it back. I can further take it down. Again I can take it back. I can take it off. But at a certain limit, you will find it falls down. The question is, why after certain angle the ball falls down?
Sir, because of the gravity.
Okay, but when it is here, he's saying it is because of gravity. But when it is here, that time also gravity is there. No, it's not that gravity acts in particular region only. Yes?
So when you put it in that angle,
Huh?
the force of exerted by the air is on the only on one side. The other side, the air is not exerting the force.
Okay. What is in short, most of you have played that something called tug of war, right? Tug of war, there are two groups. One, with both the groups are pulling to each other. Here also there is a tug of war. There is a gravitational force which is always acting on everybody. To counter that, there is another force which is called Bernoulli's force. And that Bernoulli's force, in very short, it is the force when velocity of any fluid means liquids and gases, is more, pressure drops. When the pressure drops, all the fluid in surrounding will come and try to fill that or bring it to equilibrium. Because of that, this ball is surrounded. Suppose if I disturb it from this end, the velocity of air going from this end will be higher, so pressure will drop, so the air in this side will come and support it. So it will be pushed from this end. So in all direction, it's like a cone of ice cream. So in all direction, it is supported by air molecules. That's why it remains here. When I turn it, then gradually Bernoulli's component becomes less, and there is a gravitational component. So when the gravitational component and Bernoulli's component are same, as long as Bernoulli's component is dominating, it will get balanced. But the moment gravitational component becomes more, it takes over and it falls down. It's very interesting, and let me tell you, all the aircraft which fly in air, they are based on this principle. All the birds which fly in air, that is based on this principle. The fishes which you see in your fish tank or in rivers or sea, they move around with this principle. Now the question is, who taught Bernoulli's principle to birds and fishes? Huh? Nature. Very good. Actually, nobody taught Bernoulli's principle to these fishes and birds, but Daniel Bernoulli observed the very minute things in nature, and he came to the conclusion that there is some principle which governs the flight of these aircraft or birds or fishes, and he came to the conclusion that there is something called, which when this velocity increases, pressure drops, and because of that only they can do these things. Suppose in future, any of you observe nature very carefully and come with some such principle or law, then that particular law will also be named by your name. So now it is challenge for you. So you can very well observe or very systematically study the nature and come to some conclusion. Now I will show you. Suppose I have a small ball here. Now these are two balls. The only difference is color. In all other respects, They are like identical twins. Now you see, now you have to tell me why they are not getting stabilized here. Can you tell me why they are not stabilizing? Because they are same. If I put one, it will get stabilized. But if I put two, it won't get stabilized. Why? Thank you.
Sir, because the first one blocks the air from getting to the second one.
Actually, their masses are same, their density is same. So they want to, or they try to acquire same position, and that position, if one ball is there, other tries to push it down. So because of same parameter, they cannot acquire same position because position only one. So always in real life also, first number is only for one particular stream. The one who is more studious, he only gets the first number. It is the same thing. If you have enough, what you have put enough effort, you will get that position. Otherwise, you will not get that position. Okay, we'll move to the next demonstration.